3D pathfinding in Unreal Engine isn't a 2-button setup, as much as we want it to be. But there are ways to kind of do that. If you have like a flying familiar, you can use something like a homing projectile to have it follow around, even in 3D space. What if you just want to tell a familiar to go somewhere in 3D space? Well, that's kind of where this setup will come in. As you can see, this bee is flying around these obstacles in 3-dimensional space. And while it's not a perfect system for everything, it does go ahead and show that you can set something like this up and use it to have a character or something go from point A to point B very easily, effectively along a spline, as you can tell. Now, there are a few caveats with this. This is not real-time pathfinding, where if the target location is constantly moving, it will go ahead and adjust. And it also does not account for dynamic changes to the environment. This is a set location where things are set up to be just locked in, and then it will automatically pathfind around. So for example, you can have a regular AI control, and then when you need the character to go somewhere specific, you can have it automatically pathfind. So for example, if you want a familiar to continue to follow you, go ahead and use like a homing projectile. It'll automatically follow you, make it nice and simple. And then when you want to say, hey, go over there, well, that's where you can use this setup and then just have it go where you want it. And it will just navigate around everything. The main thing of this tutorial is I'm going to show you guys how to set this up, and then you can build on top of it and kind of use some of the ideas and the new things that I'm going to show you guys to expand upon it for your own use cases. I just think this is really cool and I want to share it with you guys. So let's get into it. Now, I am using PCGEx. So make sure you have that installed and then go to Edit Plugins, search for PCGEx, and make sure you have this enabled. It is completely free, and the link to it is in the description. We'll be making heavy use of this. So now we're going to need 3 things. We're going to need the character, effectively, that's going to follow along. We're going to need something that is going to sample the environment once. It can be heavy because it only samples it once, and then another setup that then takes that sample and only does the pathfinding part of it. Because you could do all of this together. You could have it sample the environment and do the pathfinding. It would be almost dynamic then. It would be very expensive, but it would be almost dynamic. But even as it's moving along, right, things are still moving, so it's not going to update dynamically anyway. Not really for that use case. But those are the 3 things we need. Something that samples the environment, the actual spline mechanism, the actual character that moves along it. And when you put all those 3 together, then we have the setup you saw. Let's go ahead and get started with the very basic one. We'll get started with the kind of the bee, bird, flying creature. I'm just going to right click, go to Blueprint Class, grab ourselves an actor. I'll just call it something simple like BP_B. This is where you can have your character or whatever else you have here. That doesn't really matter. In here, I'll open it up, and then I will go ahead and add a static mesh actor here. And because I have the static mesh already selected in the content browser, it already shows me, there it is. So when I go ahead and add it, there's our cute little bee that's going to be following along. I got this from Kenny, like I have been for a lot of the assets I've been using in the tutorials recently. He's very cute and happy, isn't he? And honestly, as far as the character is concerned, you don't need anything. You just need something to visualize. For your setup, you're not going to need to add a single extra variable or anything else when you do this. Now, you might want to have it control some other stuff, but in terms of just having this work in general, nothing necessary. I'll close it down, and then we'll go ahead and make a new setup. Let's go ahead and make a new PCG graph by going to procedural PCG graph. I'll create an empty graph. I'm just going to call it PCG_navigation area. And let's go ahead and just drag it into the world. And this is where you can put it to be as big or as small as you want. I'm fine with the kind of the default area. That is fine with me. So let's go ahead and open it up. So I'm going to be making use of the actual volume that has come in here. So I'll open up the input. That is where we can grab the volume. If you have something else that's already presets the volume with PCG, you could of course use those, but I'll be using the volume. So I'll just use a volume sampler, and we can keep the voxel size as is. That's fine. And if I go ahead and press D on this volume sampler, you'll see that we effectively have a giant solid cube here. Very hard to tell what it is we're looking at. So if I just have the volume sampler selected, in the detail panel, we can come here and change from extents to absolute and change it to something like 0.5. And now you'll see a little bit better that it's actually a lot of small little cubes all crammed together. Okay, cool. Now I want to randomize the position of these cubes. So I'm actually going to use a simple transform points node, and I'm just going to offset them a little bit. I'm going to offset them between -200 and 200 in all axes. So if I sample this now, you can see it is now going a little bit out, but that's okay with me. The main thing is it is now a little bit more randomized in its locations. And the reason for that is just so we don't have perfectly straight navigation paths. Because what we're going to be doing now is taking these points and making a PCGEx cluster with it. And it's actually pretty simple. From the transfer points, we just drag out, search for connect, and there's a PCGEx cluster, connect points. Connect points according to a set of probes. Now what are probes? It is not the alien thing, not that kind of probe. Basically, it's the logic that the cluster uses to figure out how you want it to work. So for this probe, we can just drag out and search for closest. Probe in a given closest. So we'll go ahead and select it. And now we can say, okay, in what distance, basically, do we want to check for the nearest points? We've given it some randomness in the transform points. So let's increase the search radius to something like 300. And then we can say max connections. We don't want to do just one. We want to connect to mostly everything around. So let's set it to be something like 6. So basically within 300 units of a point, connect to 6 random points within that. If I go ahead and just drag out of edges now, and then I select a debug paths node here, we can take a look and you will see a big mess here. If I go ahead and have it not selected, you can see like all of these points are now connected all around to pretty much make a giant net. So, okay, so we're getting somewhere. We might be able to get away with, honestly, with less points. So we can do that by changing the volume sampler to something like 200, let's say, on the volume sampler front, and maybe increase the offsets now to -400 to 400. But of course, when you increase that, we're going to need to increase the search radius. We'll double that as well to 600. And now you can see it is now less dense of a kind of net here. It's a little hard to see. We can change the debug paths here and the parameter overrides, change the color. I'll make it something like a dark orange here. And you can kind of see it a little bit better. So this is kind of the net. So that's cool, but we don't want it to be everywhere here. We want to cut out different areas. So let's go ahead and add some blocking areas. Let's go ahead and add a few simple cubes around. Basically, we're just going to use these as kind of areas where we just don't want it to go through. Maybe there's something in the way, right? We just wanted to avoid these areas. I'll go ahead and just put these around kind of willy-nilly just so we can have a more interesting setup. Let's say something like this. There you go, just a bunch of blocking volumes just for the demonstrations here. You can see they're all within this area, although they don't have to be fully enclosed. But we need to specify now that, okay, we don't want these guys to go through this actual cube, right? We want it to stop. Now we're going to be making use basically of traces to do this. So how do we do that? Well, after we've made the actual setup here, all the points, all the connections, we can do a line trace to figure out if we're going and connecting between the points and going through an intersection. Now, you might think that you just drag out and search for line trace, and this is what you're going to want to use. In fact, it's not. We want to use refine, cluster refine. So in here, we can go ahead and plug the vertices into vertices, edges into edges. It's going to throw us an error. That's fine. But now we can specify the refinement. And in this refinement, we have a refine line trace. Let's go ahead and select it. Now let's go ahead and open up the refinement so we can take a look at its settings here. Here we have a two-way check. So a two-way check, from how I understood it, was basically every single point to every single other connected point is going to do a line trace if it is one way. It is not going to do it in both ways. Now, why would you want it to do it in both ways? If you have, let's say, a plane, a flat 2D plane, it is going to check the trace from one side, but from the back side, it might end up going through. So in a scenario like that, you might want to do two-sided traces to make sure that, hey, even when it's going through the back side of something, still consider it as a hit. And in scenarios where a trace starts inside of, let's say, the cubes that we have, it will automatically be considered a hit. So in our case, we're going to keep two-way check on, although in our scenario, again, it's not necessary. We don't have any planes, but we'll just keep it on. Let's go ahead and open up the collision settings here. The trace mode is align. We're fine with that. We're going to check the channel and world dynamic. Again, all is fine. We can change it to object type, and instead of trace channels, you can get object types, and you can just say, okay, I want to hit just a world static object, right? Or you could say you want the channel or a profile, whatever it is. I'll keep it on default. This is fine. We're using the default cubes. They have this already set up as the collision. In your case, if you have a custom collision channel, you can go ahead and select it, or a custom object channel. So you can filter out things you do or don't want to have affected. There's also this section to allow you to select actors and stuff to ignore. We're not going to be using that, but there's ways to customize this a little bit more if you need to. The main thing here, though, is if I go ahead and just do another debug, this time instead of using a debug paths, I'll just do a debug edges. This one just goes ahead and grabs both vertices and edges here. And we can take a look here. There's our little paths here. And if we take a look here, look at that. It is no longer going inside of the cube, right? It goes right up close to it. But if any edge here was to go inside of any of these cubes, including anything that's bigger, right? It doesn't matter. You can see we now have a volume here that is no longer going inside. If I go ahead and disable the line trace, you'll see there's our connections. If I go ahead and rename it, right, you can see those ones are going through. Same thing here, right? These are going through, so that's what we're getting rid of. Anything that's now intersecting. So we now have basically this net of wires that is now avoiding every single cube. Fantastic. So this is going to be our one-time calculation. We're not going to be doing this connect points cluster setup every single time. We do it at the beginning, and then we just reuse it. That way, this being the more complicated and expensive in terms of performance thing happens only once. So then from here, right, we can just go ahead and use this information, and we're just going to output it basically. I'll go ahead and open up the output. I'm just going to customize this a bit. So for the pins here, I'm going to say we're outputting the clusters. So let's rename it to clusters. Allowed type. There's a lot of them if you're using PCGEx now, but we just need points. So go ahead and select points. And I'm going to change the pin status because this is a required thing. We need this to work. I'm going to set it to required, that it needs to be an output here. Otherwise, something is broken. All we need to do now is take the vertices and the edges and pipe both of them inside. Don't worry about that. That is completely fine. We'll go in and filter it out where we need to. But that's really it for the sampling of this navigation area. Nice and simple. We basically created a bunch of points. We offset them randomly. Then we connected them within a range. And then we filtered out things by a trace. So now we have this net where we need it. And as you saw before, if you want it to be a little denser or less dense, you can control the amount of points and the distance between the points in the volume. Okay, so we have this. I'll keep this mesh here so you can kind of see what's going on, but you don't actually need to preview this, of course. But now we need to get the logic of actually setting up the pathfinding. For that, I'm going to need a blueprint actor. So I'm going to right click, go to blueprint class, grab yourself an actor. I'll call it BP_flying path. And we'll also need a PCG graph for it. So I'm going to right click, go to procedural, grab yourself a PCG graph that is empty, and I'll call it PCG_find path. So inside of this BP flying path, let's go ahead and add the PCG component. And of course, in the detail panel, make sure you plug in the new graph we just made for it. And I'm also going to give it a box collision. Now, it doesn't need to be specifically a box. It can be any kind of volume. But when doing stuff with runtime, always have some kind of volume. You can even go in the detail panel, search for collision, and just go ahead and turn off the collisions entirely by setting to no collision. PCG just needs to basically know where it is in the world, and this helps it, even though you're not actually using the volume for the volume. Trust me, so many things, so many bugs are fixed by having just a box volume of some kind compared to having just the PCG graph attached. Now we'll come back to this, but let's go ahead and deal with the actual PCG graph that we hooked up. So I'll go ahead and open up the PCG find path that we just made. So the first thing I want to do is actually grab the information from the world. So I'm going to right click and I search for get PCG component data. So here we go. So this allows us to grab information from another PCG graph. In the world here, we can say actor selection by tag. We could go by class. Now, our class is just a graph itself. It is not blueprint actor itself. So let's go ahead and give it a tag. I'll go back into the world and I'll go ahead and select this navigation area here. And then in the detail panel, I'll search for tag. And then all the way in the bottom here are actor tags. We'll go ahead and add a new one here. I'll just call it navigation area. And before I press enter, I'll select it all and copy it, then press enter. And now in this component data, we can go ahead and just paste in the actor selector tag here for navigation area. The important thing here, though, is the expected pins. We renamed the pin that is coming in. Our pin isn't called out. So I'm going to hit plus here, and we're expecting a pin called clusters. Because you remember here, we named it clusters. So to get clusters out, we need to add clusters as a possible input here. But now we need to split it up, right? We need to get from this cluster information, we need to grab the vertices and the edges of the clusters. To do that, just drag out of the clusters and search for find. And here you'll see PCGEx find clusters. If you go ahead and select that, it will go ahead and find the vertices of the clusters, everything you need to basically split it back up. So you don't actually need to have two separate inputs here. The one is just fine. That's why we went ahead and put it back together here as one. No need to overcomplicate it, send it all through, and when you need it, split it back out. In fact, if I wanted to, I can go ahead and grab this debug edges, and I can just go ahead and plug this in here. And let's go ahead and disable the original one here. We'll disable it. Now you won't see anything in the world yet. That's because we haven't brought this into the world. So I'll grab this BP flying path and I'll just drag this out into the world somewhere. And as soon as I do, you can see, hey, that is now in there. And you can see it is now in the world. And wherever I drag this, it doesn't really matter. As long as it's within the volume, it'll read the information it needs to, and it will go ahead and just push it through. And it's not recalculating the actual net here. It is just reading what has already been calculated and generated. So awesome, we're now getting the information through. So let's go ahead and use it. I'll re-enable the original debug edges here. I might just change the radius here to something like 0.3. So if we zoom in, we can still see all of this, but it's just not in our way when we kind of look out from a distance. So back to the find path. Let's go ahead and figure out the pathfinding. Well, there's a node for that. In fact, there's a lot of PCGEx pathfinding nodes. The one we're actually going to be using is plot edges here. Extract a single path from edges clusters going through every seed points in order. Let's go ahead and select it. And I'll explain what it does once we plug in the vertices and the edges through. Basically, you have these plots. You can think of them as just a line of points, like a curve. You just plug in the curves or plug in the points, and it'll just go ahead and calculates a path between all of them. So if you were to plug in 2 points, it'll find from one point to the other along the cluster. If you plug in 3 points, it will go ahead, find from the first point to the second point, to the third point in order, and so on and so on. But if you had 2 sets of data, then it will find 2 separate paths for each of those data points. In our case, we're only using 1 set of data, but it is much more powerful than what I'm just showing you as the kind of the base. Well, I want to go from where we start, from where the B is, which currently is nowhere in the world. So let's go ahead and grab the B and just plug it in somewhere here. Let's say it'll start from here. And then I want it to go to another random point. Now there's multiple ways of doing this. You can tell it specifically where to go. You can say it as a variable. In my case, I'm just going to use a target actor. So I'll add a new target point rather. And now we'll just tell it, hey, just go to the location of this target point. So I'll go ahead and just bring it out somewhere in this area here. And we'll just make sure it's inside the volume. Right there is fine. So I want it basically to navigate from where it is to this target point. In fact, let's just go all the way here behind this wall to make it a little more interesting for its first path. Okay, so I want it to go from here to here. So how do we do that? Well, first we need to get the location of the B. Now right click, get actor data. We want the regular spatial get actor data. And in its settings, instead of parsing actor components, we don't want to get a single point. Instead of self, we want all world actors by class. And the class, of course, is our BPB. So go ahead and find the BPB in the world and basically get its location. The other one that we want to do is the target point. So we'll just duplicate that. And on this one, the class here is going to be target point. Again, single point, everything the same. This is where, if you wanted to, you can have it find multiple locations to create kind of a path between all of them. You can also just set a variable inside of the main graph and sample it here in terms of just getting the location. That's fine. There's many ways of doing this. It all depends on kind of your use case. I think this one's pretty simple and self-explanatory, so that's where we're going with. So now we have the starting location and the end location. We want to combine the two locations by just using a simple merge points here. We want to make sure that the order here is first the B and then the actual target. So I went ahead and added a pin here to make sure that they're in the correct order. So it starts at whatever the B location is and ends at the target point. And when I have that, I can use that as our plots. So that is our plot from here to here as one bit of data. Now we have heuristics. Basically, heuristics is the logic of the pathfinding. What is it going to use for actual pathfinding? Well, we want to go by distance, the shortest distance really. So just drag out of the heuristics and you can just search for short and grab yourselves heuristics shortest distance. You don't even need to configure this in any way. Just go ahead and just plug it in. We'll just use the default shortest distance. That is completely fine. If we wanted to from here, we just use a debug paths node. And I'll just customize this a little bit by changing the color here to red and changing the radius so we can really see it to something like 10. And if you take a look here, hey, there's our little path going around all the things. And if I go ahead and move this target point over here, you'll see, hey, it's not actually following it automatically. The reason for that is because over here on the get actor data target point, we have track actors only within bounds turned on. If we go ahead and turn that off, then it will now actually follow it, as you can see here. So we can dynamically update this position and see the path that it's trying to make from one location to another. I'm going to drop this down, right? It's now trying to get around here, just like so. Same thing with the B, right? It's not going to update, but if we turn off the track actors only within bounds for the actor B, you'll be able to preview this just like that really quick. Now, you don't have to turn this on. You could do a cleanup and generate for previewing this. This is more so just for a live preview. It is not actually necessary for this to work. The path here is very rough. It'd be a little bit better if you smoothed it out a little bit. Now, something about the smoothing though, is depending on how much you smooth and how much you simplify this curve, you risk the chance of going inside of the collisions. Because if it's smooth too much, it might just go right through a wall. So be careful with how much you smooth or adjust accordingly. So let's go ahead and take care of the smoothing first. And for that, it's very simple. From the paths, we just drag out and search for smooth. And it's a paths. We get path smooth. Perfect. Let's go and select it. In here, for the smoothing on the detail panel, we can go ahead and smooth it something like 3. We don't need to smooth it that much. And we just need to plug in a blend operation. Blending configurations used by individual non-monolithic blending interface. Very complicated stuff, but basically we want to use a weight for the blend. Creates a single blend operation node, can be used with attribute filter. So let's go ahead and use this blend operation. And I just wanted to blend, smooth out the positions. So the operand A here, we hit plus, go to point position. We're smoothing out the positions. And now if we go ahead and debug these paths, well, look at that. That's pretty smooth. That's a lot better, right? Now you could, of course, smooth it even more. If I change the smooth here to, let's say, 10, right? We come very smooth here, but see what happens? This is what I mean, is because we're now smoothing the curve, it is now going through the wall. So be careful. I'll go ahead and keep mine at around 3 smoothing. It kind of still has it a bit smooth, but it minimizes the risk. At this point, you can also simplify the path. If I do something like a path resample, so if I was to use a path resample here, for example, right, we could change it, the distance here to, let's say, 500. And now you could see, there it is. It is now has a point every 500. Maybe the order of operation here would be better to first go ahead and resample it and then smooth it potentially. So if we did it this way, resample, then smooth, it's a little bit better. But again, depending on the resample amount, so let's say we did 200 here, you can risk, again, going through walls more or less. So I'll go ahead and disable the resample here. We'll just use the smooth. That's probably fine with me. But just know you can resample it, can smooth it. You could do one or the other, both, entirely up to you. But that's pretty much it. That's basically all we need from this graph, right? We have a path here from one point to the other. Now you might be thinking that, hold on a second, we're not actually outputting anything in terms of things to spawn in the world or anything like that. This is just pure data. And that's right. We're using PCG purely for the data. Because I think more people need to start doing that. PCG allows you to sample the world. And with PCGEx, it allows even more sampling of the world. So you can, using just PCG, sample the environment, figure out locations, and just output the data. Now I have a tutorial on how to actually save that data back out. And I'll make sure to link that at the end of the video if you want to know how to do that. But just think about it. You don't always have to spawn something. You could just get it for the data. So we now have the path. How do we use it? Well, I know I said that's all we need, but technically there is one other thing we need. Just one simple node, and that's just a create spline node. Go ahead and just create a spline from this path, and we just need to select from create data only to create component. And what this is going to do is, as you might imagine, create a spline component that we can now sample. Let me show you how. Back in our flying path blueprint, we can now customize a few things. Let's start with adding a few variables. I'm only going to need a couple. One is the movement speed. We're kind of going to want to control that. So let's go ahead and add that as a float variable here. And another one, we're going to need a reference to that B. So I'll call it B reference. And the type here is going to be our BPB. So I'll go ahead and select it as an object reference here. And I'll make sure it is exposed. So that way I can go ahead and select it. So now with it exposed here in the world, I can go ahead and select our little graph here. As you can see, there's our spline component and everything. Let's go ahead and select it. And then in the detail panel, we can see here's a B reference, and we'll just select it from the dropdown. So awesome, we have it now selected. And one thing to note here is it does have this spline generated already, and I don't really want that. I'm going to just go down to the PCG component and hit cleanup. This will go ahead and clean up everything, so we have nothing generated from the get-go. And then back here in the blueprint, we'll go ahead and select the PCG component, and I'm going to change the generation trigger from generate and load to generate on demand. So it'll only generate when I tell it to, not automatically when we start it. If it is already pre-generated, then it will automatically keep refreshing itself. But because we've just cleared it up, it will not generate from the get-go when we just launch into it, which is good. We want to tell it when to generate. But we also need to know when it finishes generating. So if we go ahead and just scroll down, you can see there's a bunch of events. One of them is on graph generated. If we go ahead and hit the plus button here, we get this execution. When it's finished generating, we now have a notification. We also have a reference to the PCG component, but we have that anyway, so we don't really need that much. The main thing is though, when it finishes generating, that means it's also finished generating this spline. So back in the blueprint, we can right click and search for get component by class. You want the singular one, not the multi, just the one. And the component that we want is, of course, a spline component. So we'll go ahead and select spline component here, and I'll just right click and promote to a variable. I'll just call it something like follow path. That is fine. We just want a reference to it. So as soon as it's finished generating, whatever the component is, go ahead and make a reference to it. And now we want to move along this path. So I'm going to right click, search for timeline, and then I'm going to scroll down to the bottom and then select add timeline. I'll keep the default name of timeline, that is fine with me, but I'll go ahead and double click it to open it up, and in here we'll customize it. The length here will be 1 for 1 second, and we'll add a track that is a float track. You can name it something like spline % or keep it default, it doesn't really matter. All we need to do is right click, click add key to per float, and you'll see here time and value. We'll go ahead and put 0, 0 for the first point, then we'll right click anywhere again, click add key, and this one will be time 1, value 1. So now we have 2 points. Now this is linear, I don't want it to be linear. I'll go ahead and select both of these and then just press 1. When I do that, we'll get a nice ease in and ease out. So instead of having a harsh start and a harsh end, we'll just gently go in and out from those positions. Let's go back to the event graph now. Now this is only 1 second, and we want it to be based on the movement speed we've set up. So what we can do is now go ahead and grab this timeline component, drag it out, and then we can just do a set play rate. Now we'll plug this all the way through, and the output of this is going to go into play from start. Don't put it into play, because once it finishes, it will never restart. We want it to always start from the beginning when we do this. And now the play rate effectively is very simple. We just need a divide, and if you plug this into the new rate here, effectively it is 1 divided by how long you want it to last. So if you wanted this to be 5 seconds long, this would be 5. If you want it to be 3 seconds long, it'd be 3. And this conversion basically converts it to whatever is needed to be for the timeline to be 3 seconds long, 6 seconds long, whatever it is. In our case, we want to do the math based off of the movement speed. To do that, we just need to grab the follow path. So I'll go ahead and grab this. And then we want to know the length of the spline. Get spline length. Using the get spline length, we know how long it is. And using the movement speed variable here, we can calculate what the time should be. So we just take 1 and divide it by the other, just like so. And then when we take 1 and divide it by this value, we get the duration it should be to move at the movement speed that we specified. Now in our current case, the movement speed is 0. So let's not leave that at 0. That would be a problem. Let's go ahead and set the movement speed to 1,000 by default. That seems good to me. So cool. We now have the timeline and the time that it will take for us to go from one point to the other at 1,000 units a second. So now from here, we can go ahead and use this update. So every time it's moving along, we're going to want to take our B reference and then just set actor location and rotation along the spline every time it updates. Nice and simple. So we now need to figure out where does it need to be in terms of this location and rotation. Well, we have the spline percent and we have the spline length. So let's go ahead and figure out where that is. We'll go ahead and grab the spline length and copy it here. And if we just use a simple lerp, so if I drag out of the spline percent and search for lerp, we can just use a simple float lerp here. We just need to make sure that the spline percent is the alpha. We'll be lerping between 0 and the final value. Because this is 0 to 1, this effectively goes between 0 and the full length of the spline. And that means that we now have the output of the distance along the spline at this percent. Right? Because you have a few different things from the spline. You can do get distance at, and there's a few of them like get distance along spline at location. But this is the simple one that I have found. So this is the one we're going to be using. So now we have the distance. Now we need to grab the follow path one more time. And now we can do a get transform at distance along spline. So we now have the distance. We'll plug that in. Location will need to be in world space, or rather coordinate space needs to be world space. So now we have the location and rotation and scale. We just need to right click and split the struct pin. And now we have all three. So location will go into location, nice and simple. And the rotation actually needs to be slightly modified because in my case, the B is Y forward instead of X forward. So to adjust it to be X forward, I'm just going to take this rotator and do a combine rotators, which effectively will combine two rotation numbers. We just need to offset the Z here to be -90, so it'll face forward. And that it becomes the new rotation. If your character already is facing X forward, this is not necessary. In my case, it is Y forward. So I've gone ahead and adjusted it. Now, nothing's going to happen yet, right? We haven't told it to ever generate this graph. So let's do that. On begin play, we'll go ahead and use this. I'm going to give it a little bit of a delay, so that way we have a moment to actually take a look at it. Wait for a second, and then we'll grab the PCG component and select generate. And we're going to say force generation. So that way it makes sure to generate from scratch, even when it is not generated already. So wait a second, generate it. Once it's finished generating, it will trigger this and then trigger all of this. So let's see what happens. Here we are, right? The point is right there. The B is right here. If I go ahead and press Alt S to start simulation, after a second, hey, there's the path and there it goes. Now it is just going to stop there. It's very happy about it, but it's just going to stop there. And for what you're doing, this might be all you need. The only thing maybe to do is once it's finished, go ahead and grab the PCG component one more time and just do a cleanup. We'll go ahead and clean up, remove components, basically clean everything up so that way it is no longer generated. So now we basically have a way of saying, hey, go there. At any point, we can call the generation, and as long as we have the target point in the right location, it will navigate around this entire space and continue on. But in my demo, I was showing it moving around all over the place. You can do that through basically maybe like a drone patrolling around. Just keep in mind that when it does go to the start of the new path, it will snap to the rotation of the new path. So if you want it to be a little more natural and curvy, you'll need to add a little bit of functionality for that. But that's a little bit beyond the scope of this tutorial. But basically, once it's finished, we can just drag out and do a get actor of class. We can go ahead and find the target point, because currently we don't have a reference to it. And then we can just do a set actor location. We just want to do the set actor location. We do not care about the rotation. And we'll just right click on this new location and split struct pin. And then we just need to give it a new location. I'll just right click and search for a random float in range. And we'll use -2000 to 2000 inside of X here, as well as inside of Y. We'll do a separate random float, so we'll grab two different numbers. If you plug the same one into both, it will have the same value in both. We want two different values. And I believe the height is normally not as tall, so I'll do -1000 to 1000 for the height. So go ahead and set that location, and then we just need to regenerate it. So we can just go ahead and grab this PCG and generate and plug it in right after this get actor location, compile it all. And now if I go ahead and hit simulate, we can see, yeah, there it is. It's going along the path. And then there's another path. And then it just keeps generating a new path every single time and goes ahead and follows it. As simple as that. And you can see it's going around all of the things. It is avoiding everything as needed, as simply as that. I think it's pretty cool. If you have maybe an NPC or a follower and you wanted to tell it to go somewhere in 3D space, and their flying creature, I think this is a pretty good solution. Now, assuming that the environment isn't constantly moving, of course, I think this isn't bad. Is it the best? Is it the most efficient, performant, magical, whatever you want to call it, thing in the world? No. But it does show you a few things. One, a use case for clusters, which I'm always looking for when it comes to PCGEx. And two, a use case of just PCG data. But you don't have to keep spawning things to have cool things with PCG. It has more use cases than that. Now, as always, the project files for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord and everything else is down in the description below, as always. And if you're looking for more cool ways to use PCG, check out this video right here to continue your PCG learning journey.